Hi guys, in this video we're going to go over a bit of organic chemistry. We'll speak about condensed structural formula, and molecular formula. We'll go over some important definitions and terms. We'll go over to identify compounds, or the different types of compounds, homologous series, functional groups, and so forth. And then we'll talk a bit about isomers. So let's get into it quickly. So what exactly is organic chemistry? So first you have to know what an organic molecule is. So an organic molecule is a molecule that contains carbon atoms. These are usually carbon and hydrogen atoms, but we'll understand that there are different types and more compounds that can be combined. But basically organic molecule is a molecule that contains carbon atoms, and therefore organic chemistry is the chemistry of carbon compounds. So it's chemistry involving carbon. So a lot of this organic chemistry is going to revolve around carbon forming structures. Why do we choose carbon? What's important about carbon? So let's go through. So we have here that carbon has 4 valence electrons. You should know what valence electrons. These are electrons in the outermost orbital. So the carbon has 4 valence electrons. That means carbon atom can form a maximum of 4 bonds with other atoms. And here we have the Lewis dot notation for valence electron. You should already know this from your grade 11 work. I'm not going through that again. But that's what carbon looks like, right? These carbons can form bonds with other carbons, either double, triple, or single bonds. And they don't, as I mentioned earlier, they don't necessarily have to bond with carbon. They can bond with anything else, from hydrogen, oxygen, nitrogen, etc. These carbons, when combined, can form very, very long chains. These may or may not have branches. So what does this exactly mean, right? The diagrams here will show you what I mean by carbon chain branches. So see, this is a carbon chain here. This is a carbon chain. This is your carbon chain. As you can see, everything's in a single line like that, and there's no branches. But here, that's the longest possible chain, and then that's a branch. But that's just to illustrate so that's this example of carbon chains. And just take that. There we go. So that's what carbon chains are like. Most of these times these bonds are covalent. I'm not going to go over bonds in this video. You should already be familiar with what bonds are. Right. So now, how do you represent these molecules? Like, how do you represent these chains? So, in terms of representing organic molecules, there are different ways. You can represent them using molecular formula, structural formula, or condensed structural formula. So, molecular formula is a chemical formula that indicates the type of atoms and the correct number of each in a molecule. You should be familiar with this. We did empirical formula and molecular formula earlier on, and it's the same molecular formula, right? It just indicates all the atoms and the correct number of the atoms in the molecule, right? Structural formula of a compound shows which atoms are attached to which within the molecule. Atoms are represented by the chemical symbols, and lines are used to represent the bonds that hold the atoms together. So it has all the bonds. So these lines indicate bonds between them, and the elements are represented by the chemical symbols, right? So, and then finally we have condensed structural formula. It shows the way in which atoms are bonded together in the molecule, but does not show all the bond lines. It may just show 1 or 2, like in this case here. Special case. This is a special case. But most of the time it looks like this here. This is what it looks like. But that's condensed structure. You need to know these definitions. Very important to know the definitions and know what each type of structural formula looks like. This is an example of a molecular formula. This is a structural formula, and this is a condensed structural formula. Right. Let's do a couple of examples now to give the structure and molecular formula following. Okay. First one is CH3, CH2, CH3. Right. They want structural and molecular formula. Right. So let's do number 1 here. CH3. So we have CH3 here. We have CH2 and CH3. Right. Don't forget, we don't need numbers. Just showing all the bonds and all the elements. Don't forget your H's. And that's it. That's structural formula. Just number of carbons, 3, and number of hydrogens. You draw all of them in, and if you have, that's your structural formula. And molecular formula, just have to count everything. So there's 3 carbons, and there's a total of Let's count. 3, that's 6, 8. 8, sorry, 8 hydrogens. And that's your molecular formula. Very simple, very straightforward. Right. Let's do another example. Let's do number 2 now. Right, it says CH3, so CH3, CH2, CH2, CH, CH, and you can see when this bracket here, it indicates that this particular molecule is joined to the previous one. So that means there should be another CH3 here. CH3 and CH3 again. Don't forget to add your hydrogens in. I'm just usually when I just do them all at once just to make it a bit quicker. Couple hydrogens here. Right. That's pretty much how you use. Very, very simple, straightforward, right? This is a structural formula showing all the bonds, compounds. And let's do the molecular formula. All you do is you add up the total number of carbons and the total number of hydrogens, all the elements. So molecular formula is given as 1, 2, 3, 4, 5. There's 5 carbons, and number of hydrogens, that's 5 and 6, 11, it's 12. 12. So that's your molecular formula, and that's your structural formula. Right, let's move on. Let's do another example. This time we'll go over what condensed structural formulas and molecular formula. I'm going to leave this for you as homework. You can do this as homework anytime you like. I'll post the link in the description for more homework examples as well as the solutions to the homework. Don't look at the solution when you're doing the homework. Do it and then afterwards check if you have the right answer. Okay, so condensed structural formula. Very simple, very simple, very straightforward. Similar to structural formula. So this is going to be a CH3, except not all the bonds are shown. CH3, then that's going to be CH, and CH again, and CH3. And that's your condensed structural formula. And then the molecular formula looks, so if you just count everything, there are a total of 4 carbons, and how many hydrogens? 8 hydrogens. And that's your molecular formula. I'll leave this one for you to do as homework. This one you can do as homework. Just note that there should be something in the bracket, looks like something's attached there, but I'll leave you that to figure out yourself. Right, so that's a bit about structural formula and molecular formula, condensed structural formula. You should know all of these and you should be very familiar and very comfortable using them. Let's move on now to just a couple definitions, and then we're going to naming of different compounds. Right, so what is a functional group? It is a bond or an atom or a group of atoms that determine the physical and chemical properties of a group of organic compounds. Right, so it's basically a group of atoms that determine the properties of a compound. That's how I do it. So it's a group of atoms that determines the properties of some compounds, right? So we have hydrocarbons. So that's what you need to know. It'll make more sense as we go along what a functional group is. What is a hydrocarbon? It's an organic compound that consists only of hydrogen and carbons. So that means we've done examples of hydrocarbons. If it's just CH, like you see, you've seen some of these groups. So you can see only hydrogen, only carbons. That's called a hydrocarbon, right? Now you can have, you might have seen something like a double bond, something like this. That's a double bond. That's your triple bond. So when there is a single, so these hydrocarbons can either have single, triple, or double bonds, and so the single bonds, anything with only single bonds, are called alkanes. So this is an alkane. If you see something that has something like this here, right, with a double bond, that's called an alkene, and a triple bond has alkyne. Just names for when you have different types of bonds, right? Okay, so what is a homologous series now? A homologous series is a series of organic compounds that can be described by the same general formula, or in which one member differs from the next with a CH2 group. Right. Basically, a functional group here gives the name of a homologous series, but it's these groups of organic compounds have the same general formula, or there's just a slight difference. That's pretty much it. Alcohols, you might be familiar with this. You might have heard of it. I hope you're not familiar with drinking it. But alcohols, when an oxygen and a hydrogen atom are bonded together to form an OH in a functional group, so OH, something like that. It has an OH in it, there we go, right? They form an OH. So like hydrocarbons just have hydrogen and carbons. So your alcohols can have they have oxygen and hydrogen combined, something like that, right? But we'll go into a little bit more detail later on. Another couple definitions that you should know. You really should know these definitions and understand them. What are saturated compounds? These are compounds where there are no multiple bonds between the carbon atoms in the hydrocarbon chains. That means there's only single bonds. There's single bonds. Everything is a single bond, like that. Unsaturated, obviously, that means there'll be a double or triple bond somewhere. So some things like that, and it is unsaturated. Let's do a couple of examples. Right, so determine if the following are saturated or unsaturated. Okay, let's just do this structural formula to check what this is. CH3, CH2, CH3. Can you see any double or triple bonds? No. That means there are no multiple bonds between them. Therefore, this one here is saturated. This can be your homework. You can do that. And there's a triple bond here. If there's a triple bond, 1, 2, 3, that means it is unsaturated. It has multiple bonds. Unsat. Right. Very straightforward. That's very straightforward. So I'm going to go into a bit more detail now about the different types of bonds that you can have. And these two tables here that are shown here are very, very important. You actually need to know these, and you should know them off. You should be able to draw this table without looking. That's what I did when I did the exams. I could draw these tables here without looking. I used to, and then it really helped because it gets stuck into your brain, and then you're able to recall them very quickly. But let's look at the table on the left first. Okay, and first we look at the information given here. So it's the beginning of a compound name or prefix, same as English prefix, comes from the number of carbons in the longest chain. So you find the longest chain, something that looks like that. That's a chain, right? So you look for the longest chain, and then you'll get the prefix of the name. So meth, eth, prop, or but. Then you can go up penta, etc., hex, etc., etc. You know, but these are the common ones. So we look for the number of chains. So this, for example, will be a but chain, not a but, a but chain. The end of the compound comes from the functional group. So here's your functional group here. There's a functional group, and yeah, from here you're going to get the suffix of the name. So okay, let's look at some examples here. So for example, we have remember the names of the groups that I mentioned earlier. So there's this double bond here, so it's a alkene. So from the end of the group, the suffix comes from the name of the functional group. So this is the name of functional group. We have E in here, right? And number of carbon atoms, there are 2, 1, 2. So therefore eth, and then that's how you get ethene. For example, that's an example. Then it's ethane, haloalkanes. You're just gonna have to learn these rules and definitions. There's nothing else you can do. They're not very difficult. It's just a lot to learn. The table on the right might help a bit more. It's nicely described. We got different types. So you should be familiar with these three already. Just carbon and hydrogen atoms with either single, double, or triple bonds. Then haloalkane. Haloalkane is like alkenes, right? Except you have your CH, right? You see, and this X here. X can represent either fluorine, chlorine, bromine, or iodine, right? So if it has any one of these four, then it's called a haloalkane. So you can have your normal chain, and then all of a sudden you have something like this, right? And these are all H's, just remember, all these are H's, all of these here are H's, right? Except the one here is an F. Then you understand that it should be a haloalkane, right? Alcohols will have an OH, aldehydes have a double bond with an oxygen, ketones also a double bond with oxygen, except it's in the middle between two carbons, this one's on the side. Carboxylic acids, these have a COOH in it. You can see there's two O's, a carbon connected to two oxygens and a hydrogen, and esters. So you're just going to have to learn these tables. What I'll do now is I'll just go through each of these homologous series, and then maybe it'll help you understand it more. But the only thing you can do now is actually memorize these tables and understand it, right? So let's go through some of these. So what is an alcohol? An alcohol is an oxygen and a hydrogen that are bonded together to form functional group. In other words, it has an OH in it. So sometimes you may see numbers within some of these groups. This explains it. So an alcohol has a C at the end of the chain. The OH is a hydroxyl group, so another name is hydroxyl, right? Is bonded to a carbon atom, and it's only bonded to one other carbon atom. Sorry, the hydroxyl group, the OH. Hydroxyl is OH, right? So this OH here is bonded to a carbon. There's your carbon C. This is your carbon C here. So it's bonded to a carbon atom that is only bonded to one other carbon atom, right? So there's only one other carbon atom that is bonded to. See, there's no other carbons that it is bonded to. So that's a primary alcohol, and it has butane 1-ol. So a lot of the time you won't really do this. You'll say butanol, especially if it's just one. But the two helps, the number helps tell which atom the carbon is bonded to. So this is when the C, the carbon is the carbon atoms at the end of the chain, the hydroxyl group is at the end of the chain. The secondary alcohols when the hydroxyl group is within the chain. So see, this carbon here is bonded to two other carbons, 1, 2. So there's two other carbons bonded to it. Therefore, it is a secondary alcohol, butane 2-ol, right? When it's just bonded in the carbon, it's bonded to OH here, and one other carbon. There's a 1. When it's carbon, and there's two carbons, then of course, and then there's an OH. When there's OH here, then it's 2. Then it's a butane 2-ol. And then tertiary alcohols is when the carbon is branched. It's a carbon atom has 3 carbons it's attached to. So if it has carbon, 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 there's a carbon, carbon, and then an OH, like that. So this is usually a branch. It's a part of a branch, right? So that's what carbons are. Your alcohols, and those are different types of alcohols. It has an OH. That's the thing you need to remember about alcohols. It has OH. Alkyl halides. These are also known as haloalkanes. I prefer the name haloalkanes. They're a little bit easier to pronounce than alkyl halides. So the hydrocarbons, like I mentioned earlier, these are hydrocarbons. So just C, and then your H's. And then one hydrogen atom, just one of them in the chain is replaced by a halogen. So that's Cl, Bro, So there's just one of these. So just remember, it's a hydrocarbon with a halogen that replaces it. That's a haloalkane, right? So let's do an example of haloalkane. I can't do examples of everything, or this video will become too long. But an example of a haloalkane. So let's just do this one here, and you can do this as homework. You can do the second one as homework. So 2 is homework for you, and 1 is here, right? So let's go through it. So CH. Remember when I said something's in brackets, it's attached to the previous atom. So that's your CH2. Attached to it should be bromine. Then you have a CH2 again, and a CH3. Sorry, CH3. Right. So see hydrocarbon, except replaced with a halogen. Right. So carbonyl containing compounds. A carbonyl group consists of a carbon atom that is joined to oxygen by a double bond. So carbonyl has a double bond here. So there's a double bond. See, double bonded to oxygen. See, double bonded to oxygen. That's what's known as a carbonyl. Okay. There's 2 types of carbonyls that are quite popular, that we use are either aldehydes and ketones. So let's go through them, right? If the functional group, if this is a functional group, it determines the properties, right? Is at the end of the chain. So there's your chain here. So you can see there's a chain, here's your chain here. This is the chain. And at the end of it, you see this C, O, and an H, right? It's not an alcohol. It's a hydroxyl. It's not a hydroxyl. It contains this carbonyl, right? So that's a double bond, right? The double bond with the oxygen. So if it's at the end, this double bond with the oxygen is at the end, then it's called the aldehyde. But if this double bond is in the middle, it's called the ketone, right? So that's all you have to know. So see, it's a double bond with oxygen. So these carbonyl, that's a double bond with oxygen. If it's at the end, aldehyde. And if it's in the middle of 2 carbons, then it's known as a ketone. Just another thing about writing this, I wrote this here. It says aldehyde ends in a CHO. You should have CHO, right? Not COH. Even though it's C, O, and H, we always write as CHO. Why? Because if you write OH, it confuses with the alcohol group or the hydroxyl group, right? So just remember this. This is very important, right? CHO will really is always indicative of aldehydes, and it's at the end of the group. It's important later when we do some examples. Carboxylic acids. These are very. It's actually quite easy to remember. You just need to remember. So it's like carbonyl, where it's got a C. It's like an aldehyde and ketone, C double O. Except this is also connected to another oxygen and then a hydrogen. See, there's it here. This is the connection here. This is the important part. Oxygen, and hydrogen. And they're always represented, or it's easily represented by COOH. It's the only time you'll see a COOH. Then you know it's a carboxylic acid. So very easy. So these are the keys you remember. So you remember alcohol will have OH, aldehydes will have an HO, COH, CHO, CHO. It's gonna have a CHO, not COH, CHO. This is alcohol. There's your aldehyde, and then COOH will be your carboxylic acids here, right? Let's move on. Right, the last type of one is called an ester. Now this will be covered in more detail, but this is what an ester looks like. It's when alcohol, so methanol is an example of an alcohol, ethanol, OH here, indicating alcohol, and it reacts with carboxylic acid. So there's your COH and the COOH. So there's a COOH. You can see a COOH there, right? So when these two react, alcohol, then you get an ester. Then you get your ester. This is your ester bond here. There's the connection there. So it's usually if it was a carboxylic acid, at this point here there'll be another H, right? That's what differentiates it. But in case instead of being connected to another H, it is connected to a carbon atom, and that's what makes it an ester, right? So let's go through some examples of what you can expect to be tested on. Okay, so I'm just going to go through this quickly, and then after this we'll go over isomers, and that'll be the end of the video. So this is a bit of a long video, but it covers about a quarter of organic chemistry. Okay, so they want you to find what is the homologous series. So it's quite simple. You just look at the functional group, right? So the functional group here, COOH, didn't we just say that was called carboxylic acid? So this is carboxylic acid. Alright, so as we mentioned earlier, we have C, there's a double bond, so you could think it's one of three things. It could be your carbonyl, COOH, or carboxylic, or it could be an ester, right? So then you see it's connected to another oxygen. Okay, now it's either carboxylic or an ester, but it's not connected to hydrogen at this point. At this point, it's connected to a carbon. Since it's connected to a carbon, it makes it an ester. It's called an ester, right? The CHO, remember I mentioned this, I made it very clear. If it was COH, it would have been oxygen, but alcohol, but it's not. CHO, and it's at the end, because if you draw this, it's going to be CH3, and then we're going to have a CH and an O, and that means that it has to be a aldehyde. It's not in between two carbons. If it was in between two carbons, like that, then it was going to be a ketone, but since it's at the end, like so, and it's connected at the end, therefore it has to be an aldehyde. And this was the first type of bond we learnt about. We can just say simple hydrocarbon chain, only single bonds, therefore it must be an alkane, right? A-N-E, alkane. And let's draw this here. We have a C, triple C, H, then we have a C. C again. Okay, so we know that there should be 4 bonds. There's 1 on the side. We need to have 3 more. 1, 2, 3. So then we have a triple bond here, and the rest are CH. So we can tell that this is definitely an alkyne. Right. So that's pretty much you have to know. You have to know your table very, very well, and you have to be able to identify the functional groups. Then you can get your homologous series. Okay. I know this is a bit long, just bear with me. We're going to do the last part of this exercise now. As you can go over isomers, they're not very difficult, and then that'll be the last part of this video. Okay, so what is an isomer? An isomer or structural isomer are organic molecules. So organic molecules, carbon containing molecules. So organic molecules with the same molecular formula but different structural formula. That's what you need to know. Same molecular formula, different structural formula. That's what you need to know. This can be in brackets. There are three different types. We have a chain, functional, and positional isomers that we will focus on. Right. So what is a chain isomer? A chain isomer has same molecular formula, again same molecular formula, but different types of chains. Example, butane and methylpropionate. You can see same molecular formula. Both of these have 4 C's and 10. Yeah, at least 10 hydrogens. Both of them have the same, but different type of chain. Okay, so that's called a chain isomer. Positional isomer. They have the same molecular formula as in all isomers, but different positions on the side of the chain, substituents, or functional groups of the parent chain. So examples are chloropropane and 2-chloropropane, or butane and 1-butane, right? So as you can tell, same molecular formula, you can easily tell it's exactly the same molecular, but they're in a different position. So that's why it's called a positional isomer, different position. The Cl here is in the middle at 2, and the Cl in this case at the end. Right? The number, you'll see this come up quite often, tells you where in this case the halogen or whatever functional group is on the main chain, right? So that's 1-chloropropane. So you can see this at 1. So you know that you can read chains either from the back or the front. It's the same thing. So even if this was inverted, it would have been the same thing, right? And so remember, same molecular formula, but different positions on the chain. For example, we saw this example earlier when we were talking about alcohols, where the butanol, you could have 2 butanol and 1 butanol, same molecular formula, but different position. And it's now the same sort of example is being shown by butene. Okay. Finally, the last type is functional isomers. They have the same molecular formula but different functional groups. Example is methanoate and ethanoic acid. Remember we said that your carboxyl group with a COOH can be quite similar to ester, and this is an example of that, right? Okay, so we'll just do an example now of what isomers are. They require you to match these columns here. It's only 3, and yeah, they want you to match the columns, and these are all isomers, so you need to match this. So what you do with this when you're given something is to just write down the molecular formula. That would be the first step, to write down the molecular formula. So for the first one, we have 3 carbons, and we have about 8 hydrogens and 1 oxygen, right? On this side, let's move on to the next one. We have a total on this side of 4 carbons and we have 10 hydrogens. This one's straightforward. You can just count here. We have, again, carbons here are 4, hydrogens 10. This one here, how many carbons do we have? Let's see if there's anything else. Nope, that's it. We have a carbon 5, the hydrogens are 10, and we just have 1 oxygen. Again, let's write down here. Can't see that clearly. Okay. How many carbons do we have? We have a total carbon number of, in this case, 5 carbons. How many hydrogens do we have? We have 10 hydrogens. And how many oxygens? We have 1 oxygen. And again, the last one, how many carbons? You have 3 carbons. How many hydrogens? You have 8. And then we have 1. Right, so do you remember the definition of an isomer? We have same molecular formula and different structural formula. Okay, so now we just match the molecular formulas and you get it. So obviously these match, so that's a match there. C3 was a C3, these match, and obviously that matches. So it's very straightforward. All you have to do is just write the molecular formula and you'll be able to tell the isomers. Okay, the last thing I'm going to give you is an example here, carboxylic acid. I just want you to find the isomer of that. So that's about it. That spoke about a lot. We did a lot in this video. We went over naming of different compounds in the different functional groups, homologous series, went over isomers, so many different things. I'll put a link in the description to more examples and some more explanations, some videos. There'll be past papers as well as exam guidelines. The most important thing for me, I think, that you need to learn is definitely these tables that we went through here. These tables are very, very important. When you know these tables, it makes chemistry a lot easier. So you just really have to just learn the table. You should be able to write this table and then understand what you write. That's pretty much how you do this chemistry. This is the first part of the organic chemistry series. We'll do a couple more videos to cover more of it. It's one of the biggest chunks along with acids and bases. But that's about it. Thanks, guys.